Welcome back to our second episode on Kuhn's paradigms. Today we will explore the contributions of Kuhn's theory and some of its limitations. First off, in order to appreciate Kuhn's contributions, we must highlight one of his biggest critics, Popper. As we heard in episode 1, Popper has a few criticisms of Kuhn, and among them is Kuhn's account of science. He says that it's a merely descriptive one and therefore doesn't count as a theory. Popper calls Kuhn a mere historian of science. Chalmers, however, disagrees. He argues that Kuhn's account is a theory of science and it is based on a structure, or a framework, if you prefer. Chalmers says that unless the descriptive account of science is shaped by some theory, no guidance is offered as to what kinds of activities and products of activities are to be described. To bring the point home, he states that Kuhn's account constitutes as a theory of science because it includes an explanation of the function of its various components. Both normal science and revolutions serve necessary functions of science. The function of normal science is viewed as the opportunity to develop the details of a theory. It is necessary to work within a paradigm of normal science for a while in order to fine-tune theories that can explain the natural world and therefore match our current understanding of the world to what we see around us. It is through the confidence in the adequacy of the current paradigm to describe the natural world that any work can get done. Kuhn argues that scientists do in fact need to remain uncritical of the foundations of a framework for a while in order to devote their energies to attempt to solve detailed puzzles within that specific framework. Basically, don't go all postmodern deconstructivist on it because otherwise, no work would ever get done. Kuhn argues that the function of revolutions is scientific progress. For a revolution to occur, however, he states that science should contain within it a means of breaking out of one paradigm and into a better one. As was mentioned in episode 1, the incremental buildup of anomalies is precisely that set of trigger mechanisms that would create a crisis. Revolutions, as Kuhn argues, are essential for progress. The pervasive influence created when a paradigm goes unchallenged can only be replaced with a new one through a revolution. This notion of progress is the alternative to the cumulative, inductivist view of science. Now we will look at the main principles of Kuhn's theory that are worth mentioning. Scientific problems or puzzles must be worked through within a particular paradigm of normal science for any work to be done. We talked about this in the last section, and it is worth mentioning again. One of the merits of Kuhn's accounts of science is this very idea that in order to do any meaningful work, you have to have a framework whose fundamentals are not constantly under attack. That's what philosophy is for. Another merit of Kuhn's theory is that revolutions don't just come out of thin air. A system of normal science builds up to a crisis until it reaches the thresholds at the edges of that dynamic equilibrium, and then the revolution occurs at the boundary, and a new paradigm is created. However, it takes a really long time to work through and refine a particular scientific problem within an accepted framework. Without devoting a considerable amount of time to the solving of puzzles, a revolutionary challenger, so to speak, would not necessarily exist, since the problems that cause paradigms to break down would not be recognizable in the first place. Take the 200 years of detailed work within the Newtonian paradigm and the other century it took to come up with the theories of electricity and magnetism as an example. It took that long to reveal the problems with the paradigm for Einstein to then be able to make sense of these problems and propose a radically new way of thinking about them. He redefined concepts, thereby making a major contribution to the advancement of science through a revolution. And this revolution led to a new normal science. Kuhn argues that the validity of a field of study cannot be ruled out solely on the basis of falsification. All sciences have issues in the form of problematic observations or experimental results. Take astrology and astronomy, for example. Kuhn suggests that the difference of calling astrology a pseudoscience and astronomy a science does not come from the mere falsification of its claims, but rather from the fact that astronomers sit in an advantageous position over astrologers. Astronomers can test for disturbances through instrumentation and mathematical modeling, and then they can refine the instrumentation and retest results again to make them reliable. Astrologers cannot. It is in this way that Kuhn's normal science serves to identify the crucial element of testability and reliability. Paradigm shifts do not merely involve replacing one set of claims with another, but they involve a complete shift in how the world is perceived. Popper and Kuhn agree that scientific progress involves the critical overthrow of theories. However, where they differ is that Popper sees the replacement of one theory by another as merely involving the replacement of one set of claims with another set of claims. In contrast, Kuhn's scientific revolution stresses the non-cumulative nature of the advancement of science. A revolution is a complete switch of the lenses through which you see the world. This means that all of the claims, entities, evidence, and modes of explanation change from one paradigm to another. This also implies, however, that what constitutes as a problem within science can change from one paradigm to another paradigm, and that the standards of adequacy and value also change. While this is not a problem in itself, it does raise the question of whether or not one paradigm can be judged as being better than another. Which brings us to the unsettling ambivalence of the concept of progress through Kuhn's scientific revolutions. One of the major criticisms of his theory is the charge that Kuhn has put forward a relativistic view of scientific progress, and one that is very difficult to get out of. Given Kuhn's very notion that each paradigm presents a new set of beliefs, values, and assumptions, and that the standards of adequacy depend on the paradigm, it's easy to see that the idea of progress becomes problematic. From this relativistic perspective, scientific progress is relative judgment, and therefore you can never claim progress if you cannot judge, in the absolute sense that is, that one paradigm is better than the one it replaces. However, is it really necessary to be that radical? Kuhn describes paradigms as incommensurable or incompatible with each other. The degree to which he defends this incommensurability varies, but the reason for this argument is that the moment the decision is made to switch from one paradigm to another, the latter is immediately abandoned in favor of the former. Kuhn describes this moment as a gestalt shift or shape shift. Many have argued that this incompatibility creates a breakdown in communication and prevents any kind of useful comparison to assess the validity of one paradigm over another, and that it may, in fact, take away from the value of science. However, rather than concentrating solely on the subjective knowledge of paradigms, that is, the interpretation of value and judgment of the observer, let's look at the ways in which objective characteristics of a paradigm and objective relationships between paradigms can be defined. Kuhn would argue that regardless of which paradigm we subscribe to, that subjectivity should not take away from the validity of science as process and its ability to be accurate and reliable within any given paradigm. In fact, he might argue that what is important is to think about the nature of science itself and how it has changed over time. From this historical perspective, we might be able to identify the objective relationships we're looking for between paradigms. And with that, we conclude our segment of today's show. Join us tomorrow for our last episode as we attempt to reconcile concurrent paradigms. What was that, Dr. Kuhn?